Now we have a problem from the 2000 British Math Olympiad that uses the AMGM inequality. So here, we're going to try to find the minimum value of this sum. Now, when we look at the sum, when we directly try to apply the AMGM inequality, it doesn't really work because we cannot produce a constant as the bound. But we don't have to just tell us that there are only 4 terms here. We can split terms up to create more terms. So let me show you what I mean. We can rewrite this sum as x squared plus 2xy plus 2xy plus 4y squared plus z squared plus z squared. Now, why did I do this? Well, I did this because I wanted it such that whatever we have on the right-hand side of the inequality, inside the radical, we're going to have x, y, z to some power. For example, if we directly tried to apply the AMGM inequality to the original expression, we would get that this part, the sum, is greater or equal to 4 times the 4th root of 32 x to the cube, y to the cube, z squared. And when we look at this, it's hard to deal with because we can't really simplify this variable part very much because the exponent of the z is different from the exponent of the x and the y. But now, after we've transformed, or at least split apart some terms, when we try to solve for the right-hand side, here is what we get. We have 1, 2, 3, 4, 5, 6 terms, so we multiply 6 on the outside, times the 6th root of the constants multiplied to be 16. We have x to the 4th, y to the 4th, and z to the 4th. And now would you look at that? We have a power of 4 for each variable, which means now we can apply this piece of information that the problem gave us. So when we go ahead and simplify, we have 6 times the 6th root of 2 to the 4th power times 2 to the 5th power, which is 32, to the 4th power. This is the same thing as 2 to the 4th times 2 to the 20th. So now we have a 2 to the 24th under the radical, and then applying the properties of exponents, we have 6 times 2 to the 4th power. So this is the same thing as 6 times 16. So our final answer is 96. The minimum value of the expression is 96.